Today's lesson is on 6.4a, surface area of prisms and cylinders. Now, surface area is again talking about the amount of area required to cover the outer faces, like wrapping a Christmas present. You would cover the surface area, right? So prism is a solid that has two congruent faces, which are called bases, that lie in parallel planes, like a box. We could also have things like over here, this would be called a hexagonal prism because we have a hexagon base. Now, most of what we're going to be dealing with today is a rectangular prism, right? So that could look like this shape, and unfolded would look like this, where this right here, these two are the bottom and top. We've got our sides here. And generally, to get the surface area formula of that, you do 2 times the base plus perimeter height. Now, since we're dealing with specifically a rectangular prism, the area of the base is length times width, and perimeter is 2 parentheses length plus width. So filling those in, we get our final formula here of 2 length times width plus 2 parentheses length plus width parentheses times height. So moving to the first example, we have find the surface area of the solids, and we've got our formula here for us. So first we need to label the diagram. Generally, I would say this is my length, so I label it L. This one is my width, so I label it W for that bottom base. And so my leftover 6 feet is my height. With that information, I'm just plugging those numbers into their coordinating spots. So 10 is going to go where the L's are. 8 is going to go where the W's are, and then H is going to have 6 where that is. So plugging that in, I got 2 times 10 times 8 plus 2 times parentheses 10 plus 8 close parentheses times 6. And then that's just calculator work, right? 2 times 10 times 8, 160 plus 2 times 10 plus 8 plus 6. And we get a total of 376 feet squared. So surface area is always going to be feet squared or square units, right? Because it's area. Next, we've got find the surface area of the solids. Same idea, just bigger units. So here we got a 20 foot by 15 foot and 25 foot high. So 20 foot is my L, 15 is my width, 25 is my height, and I'm just plugging them into the same exact formula. So 2 times 20 times 15 plus 2 times parentheses 20 plus 15 for the perimeter, and then times 25, right? So right there, calculating the values, right? Just putting in my calculator, I get 2,350 feet squared. Okay. Next one on the right, same idea. Label your sides. And a little note, if someone switched the width and the length around, would you still get the same answer? Yes. If you switch the width and height around, would you get the same answer? Yes, same thing. So these are interchangeable. I just generally label that first lowest one length and the side one width, and then what's left over height. That's generally how I've done it. Plugging it in, we get 2 times 14 times 11 plus 2 times 14 plus 11 times 15, right? Same formula, a little bit larger numbers, and again we get 1,058 feet squared. Again, make sure you have the formula written down, and we're just filling in the blank once you label what is what. Okay. Feel free to pause if you need more time to write in. I will also post the notes on Google Classroom. Next one, 12 and 5, length, width. 10 is my height. I'm not labeling it physically anymore, but if you need to kind of do something like that on your own paper so you know what's what. Sorry, not the greatest looking L, but the general idea. Right? Then we have them labeled, and then you're plugging them in. So 2 times 12 times 5 plus 2 times 12 plus 5, 34 times 10, giving you 460 meters squared. Okay. Another time, same story over here. Again, what if you did width and length and height? You're still going to get the exact same answer. 2 times 21 times 14. Plus 2 times 21 plus 14, parentheses, times 32. All right, there's our work. Plug it in, 2,912 feet squared. Again, feel free to pause if you need to, or check out the notes online. But once you get the idea, it's pretty straightforward. Write down the formula and then plug it into your calculator. I do expect for your work something like this where you have the information plugged in. Okay. Next, surface area of a cylinder, right? If we had a cylinder like this and unwrapped it, you would end up with a rectangular area for the rounded part, and the top and bottom would be two circles, right? And so it's the exact same formula as the last piece, but instead of 2 base being a, you know, length times width, we got base being pi r squared. And instead of perimeter times height, we've got 2 pi r circumference times height. So 2 pi r squared plus 2 pi r h. Notice we have less labels. We just need radius, which again from center to the side, and height. So radius and height. If they give us diameter, we need to divide by 2. So we'll talk about that when we run into that. First example, I have them labeled for you already. 4 here is from the center to the side, so that's my radius. 6 centimeters is my height, right? And then I just need to plug it in. So 2 pi times 4 squared. And again, only the 4 is squared, plus 2 pi times 4 times 6. And again, we have pi, so you definitely need a calculator for that. 3.14 is an okay replacement, but you will be off a little bit for my answers. And we're also always rounding to the second decimal. So plugging it in, 2 pi times 4 squared plus 2 pi times 4 times 6. Calculating, I get 251.33 centimeters squared. And again, these are rounded, and I use the 3.1415, right? The pi button on my calculator, not just 3.14. So if yours is 3.14, you're going to be a little bit lower than my answer usually. Next one, same idea, but we've got 2. 9 is radius, 8 is height, and I'm plugging it in. So 2 pi 9 squared plus 2 pi times 9 times 8. Now, last set, we could switch numbers around and be okay. You cannot switch 8 and 9 around and have the correct answer. You do need to correctly label that r is 9 and my height is 8, or you will not get the correct answer. Calculating that, I got 961.33 centimeters squared. Next one, we've got 10, but the line goes all the way across. And then we have 12 for my height. So this is height, this is diameter. So again, both of these are radius, so I need to divide it by 2. So 10 divided by 2 is 5 is my radius. And now I'm ready to go because I got r and h. Plugging it in, 2 pi times 5 squared plus 2 pi times 5 times 12, right? 120 pi there, 50 pi there. So 170 pi is going to be in the 500s, and 534.07 inches squared is my final answer. Again, if you need extra time to write down these answers, the filled in notes again will be on Classroom. 2 more. Again, you're asking, is it radius or diameter? This one goes all the way across. We need to divide by 2. 24 divided by 2 is 12. And again, that's because this is a radius and this. So we have 2 of them. That's why we need to divide by 2. So now radius is 12. Height is 20. And then we're plugging it in. 2 times pi times 12 squared plus 2 times pi times 12 times 20. And we're going to get a really big answer because this is a lot of pi. 2,412.74 inches squared. Last one, we've got 15 for radius, 15 for height. So just plugging in 15 for r and h. Looks something like that. And again, that's the work required. I know you're doing most of these on your calculator because that's what I told you to do, but you still need to show me what you plugged in case you get a wrong answer. So again, note, if this is what you wrote, and then your answer was not this, and wasn't with the 3.14 either, let's say for some reason you got 1800 something, I would still give you extra credit for the work here, right? You'd usually get like a minus half if this was the exact correct answer, but this was not the same equivalent value. So it's always good to show that work, and you kind of need it written down to plug it into your calculator anyway. And that's going to wrap up today's lesson. Again, you've got the worksheet packet to work on for homework.